Okay, in this video, I'm gonna talk about the electrons circulation in magnetic field, and you will see a lot of this type of cartoons, and the electron or proton go in circulation like this way in magnetic field. So this is something we're gonna deal with in this video. Okay, so let's go with the basic idea about this type of situation. Okay, so when things not limited to electron, but including electron, go in circulation, so like this type of situation, always the inward force has to be there, and basically in order to counteract the centrifugal force. So when something is going this circulation, always this object is gonna feel the centrifugal force. So without inward force, this circulation is not going to be there. So always the inward force has to be there, and in this case, of course, this electron circulation in magnetic field case, the inward force is going to be the magnetic force. And it is kind of important because we are going to calculate magnetic force, and so you're gonna use the right hand rule, and you always remember that this FBI, and F is always middle finger. It's kind of easy to remember, and you are going to use the I, which is current, but it's always important to remember that the definition of current is the flow of positive object. So the electron, the direction is opposite to current direction, electric current direction. So opposite. So when you deal with, for example, proton flow, the direction of proton flow is same as the current flow because proton is positively charged. But this is kind of confusing part. So you have to make sure that you know that what is current direction. And like I said, you're gonna use FBI rule, the right hand rule. So remember that F is force direction, B is magnetic field direction, and I is current direction. And in this magnetic force, the equation to get force is F equal B, this is magnetic force, and Q, this is charge, and V, this is velocity, and sine theta. But in this circulation problem, this is most likely 90 degree. So in short, you just can remember that this is V, Q, V. And of course, you have to deal with magnetic force, which is inward force, and outward force, which is centrifugal force. And the centrifugal force is calculated as m, which is mass, and v, which is velocity square, divided by r. And if you see this one, inward force and outward force has to be always equal, because this is like I said, the magnetic force is there to counteract centrifugal force. So basically, with this type of equation, what you are going to get is this equals to this one. And you can cancel out this p, and most likely you have to calculate the radius of the circulation, and this r is just moving here, and this pq goes to here. Then r can be expressed as mv, mass velocity, divided by b, magnetic field, and q, which is charge. So this is all you have to know, and let's start solving a problem. This is kind of complicated stuff, but with this small knowledge, you should be able to calculate it. Actually, this is related to synchrotron programs, so this is kind of state-of-art problem. Okay, the problem is an electron traveling at 100 kilometer per second is entering a region with a uniform magnetic field. The strength of the magnetic field be equal 20 Tesla. Calculate 1. Force acting from the magnetic field on an electron. 2. Period of its circulation in the field, i.e. how much time it needs to make one whole revolution. Okay, so the first problem is you are going to obtain the force acting, basically magnetic force. So the calculation is basically F equal B, Q, and V, which is velocity. And remember that this F is vector, and now you are only care about the magnitude, which is absolute value. So let's put absolute here so that you won't get confused. And another things you have to know is Q, which is in this case electron, is negative 1.6 multiplied by 10 to the negative 19th, which is Coulomb. So this is something you can know. Okay, so just let's use this equation simply. Here, B is 20 Tesla. And Q is this one. And V, velocity, is 100,000 kilometer, but the standard unit is meter per second. So if you wanna write in meter per second, it's going to be 10 to the 8th meter per second. And what you have to do is just plug this number into this equation. It's pretty simple. Equal 20 multiplied by 1.6 10 to the negative 19th. Because this is absolute value, I'm gonna eliminate this negative. And V, which is 10 to the 8th. And if you calculate this out, you are going to get 3.2 multiplied by 10 to the negative 10. And the unit is Newton. So this is the answer for one. And the second one, the total, basically the period of its circulation. So how much time it needs to make one whole revolution. So basically the idea is, so this is the circulation, right? And if you know the length of this circulation, because you know the speed, you can calculate out the time. So basically, we wanna know the length and divided by speed equals to this answer. And this length can be calculated as 2 pi r. So let's say this radius is r, and because this is circulation, the circle, you can calculate using r. So our strategy is we gonna get r first using the equation that I gave, and with this we can get the answer using this equation. So let's get r first. So r equal bq divided by mv, right? And again, this is also you if you plug q if you plug negative number into this q, you're gonna get negative number of r, which is kind of possible, but it's kind of confusing. So let's put the absolute number here, and basically what you have to do is just plug all numbers in here, and sorry, and plus, so then you have to know the mass of electron, which is 9.1 multiplied by 10 to the negative 31. So this is kilogram, so which is standard number, and you're gonna plug in this number in here. B magnetic field is 20 and Q is 1.6 multiplied by 10 to the 19th. And yeah, I mean, I need you to use some calculator or something like that. Then you are going to get 3.5 multiplied by 10 to the 4th, which is meter. So now we got this R, and now we are going to get length by using this equation. So the length is 2 pi. This number is going to be plugged into this R, multiplied by 3.5, 10 to the 4th, which can be calculated as 2.2 multiplied by 10 to the 5th meter. So this whole circulation, the length of whole circulation is 2.2 10 to multiplied by 10 to the 5th. And you're gonna plug this number into here. So the period equals to length, which is this one, 2.2 multiplied by 10 to the 5th divided by this speed is known, like this one, velocity, 10 to the 8th. And the answer is 2.2 10 to the negative 3rd. And the unit is second. I hope this was kind of easy enough to understand. So if you have any question, please give me a comment in the comment section.